Lesson 23, Important Characteristics to Describe. Example 3. A random sample of 20 sentences was selected from J.K. Rowling's book Harry Potter and the Sorcerer's Stone. The length, in words, of each randomly selected sentence is given below. Use appropriate descriptive statistics methods to describe the important characteristics of this sample. So, to describe the important characteristics, we need to focus on the three main aspects: the distribution, the central tendency, and the dispersion of this data. So the sample data here is quantitative data. And we could use our TI-84 calculator to help us with descriptive statistics to describe these results. So on the TI-84 calculator, we can enter in this data. To enter the sample data into the TI-84 calculator, we press Stat and Enter to enter the list editor. And then we can choose a list, let's say list 1, and enter the data one at a time followed by Enter, starting with 23, Enter, 12, Enter, 6, 25, 11, 20, 9, 19, 15, 8, 20, 3, 11, 30, 7, 11, 5, 14, 22, and finally 17. Enter. Now we could calculate statistics by pressing Stat, right arrow to calculate, press Enter to select one of our stats, and then list 1 is found by going second, the number 1. Pressing Enter, we get the statistics for this sample data, which shows that the sample mean x bar is 14.4, and the sample standard deviation S sub x is 7.373. In, the sample size is 20. Down arrow, we can see more results, including the min x, which is the minimum sentence length in the sample, which was 3, and max x, which is the maximum sentence length in the sample, which is 30, and the median, MED, which is 13. In order to determine whether we need to calculate the mean or the median as our measure of central tendency, we need to see if we have any outliers. Outliers are the extreme data values. They're so extreme, their standard score is either +3 or higher, or -3 or lower. So we will calculate the standard score for the minimum and the maximum data values to see if we have any values that are in the outlier status. So the standard score for the minimum value 3, we would press left parenthesis, and then the data value 3, subtract the mean 14.4, right parenthesis, divide by the standard deviation 7.373. Enter. So here we get a standard score of -1.55, which is definitely not an outlier. Now for the standard score of the maximum data value, we'd press left parenthesis, and the maximum data value, 30, subtract the mean for all the sample values, 14.4, right parenthesis, divide by the standard deviation for all the data values, 7.373. Enter. Here the standard score is positive 2.12, which is greater than 2, which makes it an unusually long sentence, but it's not extremely unusual or considered to be an outlier. In order for this to be an outlier, we need to see a +3 or higher, and 2.12 is not +3 or higher, so we do not have any outliers in this sample. So, the appropriate descriptive statistics method to use when we have quantitative data with no outliers is to construct either a distribution table, histogram, or stem and leaf plot to display the distribution of the data, and to calculate the mean to describe the central tendency of the data, and to calculate a standard deviation to describe the dispersion of the data. So we've already used the TID4 calculator to calculate the mean and standard deviation. The results were that the sample mean, x bar, was equal to 14.4 words. And the sample standard deviation, S sub x, was equal to 7.4 words. Now we could also use the TID4 calculator to construct a histogram with this data. So we'll construct a histogram to display the distribution of the data. To use the TID4 calculator to construct a histogram, we press second, y equals, to get to the statplots command. Press enter to select plot 1. And with the cursor blinking on, we press enter to make sure it's turned on, so when we press the graph button, this histogram will be displayed. Down arrow, we then need to select the type of graph we're going to make. So make sure the histogram icon is selected. You can do that by moving the blinking cursor over to the histogram, pressing enter to select. Down arrow, XList is the list where the sample data is stored. We put this sample data in list 1, so we would press second and the number 1 to get list 1 to display. Enter. Freq is short for frequency, and in this course the frequency should always be 1 because in this case the sample data collected, each number in the list came from one sentence, which is typically the results that we have. So now with the stat plot set up, we then need to press the window button. This is where we set up the x-axis on the histogram and the y-axis. X-min is the beginning of the x-axis, x-max is the end, and the x-SCL is the scale, or the amount by which we're counting by. Now in this sample, the minimum data value was 3 words, and the maximum data value was 30 words. Now we do not have to start exactly at the minimum and end exactly at the maximum. We just need to make sure that the range includes this entire range of data. So we could pick any reasonable value that occurs at the minimum or somewhat before, or we could pick any reasonable value that ends at the maximum or somewhat after. So looking at this data, I think it's reasonable to start at x-min of 1, enter, and then go to an x-max of, let's say, 31. Enter. So that covers the entire range of data. And then going from 1 to 31, I'd like to count by 5. So the x scale will be 5. Enter. The y-min, y-max, and y-scale are the values that define the y-axis, which is the frequency axis on the histogram. The y-min is always 0, because the minimum frequency is 0. We always start our count at 0. Enter. The y-max is not yet determined. We haven't constructed the histogram yet, so we don't know what it is. So we need to give a reasonable guess. And a reasonable guess is the sample size n. In this case, there were 20 sentences divided in half. 20 divided in half is 10. Because typically we don't get more than half the data falling into any one of our bars in the histogram. But if it does, we could always go back and rechange that value to get an appropriate scale on the y-axis. And then as we go from 0 to 10, we could set our y-scale to be, let's say, 1, counting by ones. Now to display the graph, we just press the graph button. And here's the histogram of the length of sentences in our sample. Pressing the trace command, so looking at the resulting histogram, we see that the pattern starts off with lower frequencies, and then it gets higher frequencies at the center, and then lower frequencies again towards the end. This low, high, low pattern, which exhibits a symmetric shape, that is, it extends about the same amount below the center as it does above the center, is referred to as a bell-shaped distribution. So now we could take each of these results, and then using words of the problem, we can come up with a useful description of the data. The length of sentences sample from J.K. Rowling's book, Harry Potter and the Sorcerer's Stone, exhibits a bell-shaped distribution with a mean sentence length of 14.4 words and a standard deviation of 7.4 words.